Hello everyone and welcome to Homework Response. So for this week, you were working with the NumPy arrays, right? That was the main thing. So yeah, most of you did everything quite fine. So there are just few little things I want to mention. So uh, some of you already know how to use for loops or while loops, or you heard about them. So you were using them for working with the arrays. Is not bad, but at the same time, actually, lots of those actions, like when you're changing a part of an array, I mean, copying and pasting one array into another is much faster, much more clear, much more much more better solution than using some for loop. So um, anyway, I would recommend everyone, even though if your experience is much better than where we are at this point, please try to use in the homework uh, only the tools that we have introduced so far. So nothing more advanced. So you can practice that, because of course lots of problems can be solved in lots of different ways, but yeah, like I said, sometimes if you have too advanced tools, then you deal with very simple problems in a very awkward and complicated way. All right. Uh, and yeah, and so I realized that I made a mistake last week. So this week I uploaded both this commentary plus the solution of the homework. So please check the solution that we provide for us, compare it with your code. Your code does not have to be exactly the same, but let's try to get to try to understand our code, try to understand your code, and try to compare them. I mean, it's not just about how long is each code, but also if you feel like, oh yeah, they're doing way less operations than I'm doing in my code, or oh, this is like much smoother way to do things. All right, uh, so this is also important to read different solutions of different people to the same problem. Some are, let's say, equivalent, but some are uh, they're nicer in whatever that means exactly. All right, and so for some details, I've seen a few little mistakes, but so let's just get to it quickly. So yeah, a number list. Look, I mean, yeah, creating a list or an array. So still, some people wrote something like this. I mean, array and equal, and now they wrote here numbers from 1 to 20. I mean, that's a lot of work. That's a lot of tedious work. And what if I told you make a list of 100 numbers? You would not want to write that down, and it's a nonsense. I mean, that's why we have the computer. So that's why we introduced this function arrange, right, where you just write, the name of the function, and you just write, yeah, write numbers from 1 to 21. 21 is exclusive, so it's gonna create you exactly the array with the uh, with the with the lists, with those numbers there. So this is why we use computers. So whenever you see yourself repeating some action, writing a same line of code several times, uh, being just writing like 1, 2, 3, 4, 5, stop yourself and think. At that point, probably you're making a mistake. Yeah, the code. That's why we have the computer. The computer repeats everything for millions of times. The computer doesn't mind. We mind. We want to save our time. Okay. Then as for the matrices, still, or for the I'm sorry, for the endian for the arrays, I could see, yeah, that some people they're trying to create a two-dimensional array, but they had an issue. So look at these three lines of code here. So let me run this. So here we're creating one-dimensional array. How I can tell is, well, I just have these square brackets, and then I just have numbers 1, 2, 3, 4, 5 separated by commas. So this is going to make me what you would call a vector or a 1D array, just a line array, right? Now, if I want to have a two-dimensional array, that means it has rows and columns, so I have to write the rows. So first I make these outer brackets, and then these are for whatever you put between those two brackets. Those will be the rows. And now you see that for each row here I put another array. So I'm putting basically one-dimensional array inside of the one-dimensional array. So yeah, so maybe it's better if I go back here. So here, look at this. So here I'm gonna make an array that has it has two. Actually, yeah, these arrays, it's written like a, yeah, but no, okay. It's better to now to imagine this, that these are like rows. So in first row there is number 1, and in the second row there is number 2. Now that means it's 2 rows, 1 column. Now instead of number 1, I'm gonna put another array, and that has three guys, and instead of 2 I'm gonna put another array, and that has 3 guys. So now I still have 2 rows, but now I have 3 columns. Now I have 3 columns, and you can go on like this. So now here I'm creating a 3-dimensional array. So you see that in the position of what I had here, instead of okay, we'll make this smaller again. Oh, sorry, I'm not there. So now instead of the one here, I put here again an array, 1-dimensional array with 1, 2. Instead of 2, I'm gonna put here 3, 4. Okay, so that's what normally, if we had a 2-dimensional array, now on the first entry where normally you would have a number, you put an array, and it, so you think now that's gonna go in that 3rd dimension, right? In that 3rd dimension, and so on for each of the entries. Okay, I always, instead of the number, so I have a 2 by 2 array, and now instead of entry that would be 1-dimensional, I'm gonna put a 2-dimensional entry. So it's a 2-dimensional array, and I'm added 1 more dimension, so it's a 3-dimensional array. You don't have to bother yourselves with the 3-dimensional arrays at this point. It gets kind of confusing, but if you want, you can take a look at it. Of course, people use n-dimensional arrays, then it gets even more crazy. I mean, for most of the time we'll be using 2-dimensional arrays, so like I said, you don't have to bother yourself with the 3-dimensional now if it's too much for you, but you can also kind of take a look at it. The function reshape, so really important thing. Look, I write this code here, I run it, and look what it says. Cannot reshape array of size 22 into shape 6 by 6. Well, of course, because I'm gonna create, here I have an arrange function, so that creates an array of length 22, it has 22 entries, and you want to shape it into a 6 by 6 matrix, 6 by 6 array. 6 by 6 array has 36 entries, so you have to give it 36 entries, like here. Right? And yeah, and I'm sorry, in the homework it got a bit confusing. We said fill it with numbers from 1 to 36, and then there were numbers 0 to 35. Yeah, that's what happens. I mean, for the actual code, it really didn't matter, right? If the array had 1 to 36 or 0 to 35, that really had no influence on what you were supposed to do. So don't worry about that. And so this brings me to the last thing that surprisingly only one person noticed, or the way they wrote the code, they noticed this. And then there is something a bit strange when you are creating a one variable from another. So let's take a look at this. So here I'm going to creating this array again. It's a 6 by 6 array with numbers 0 to 35. All right, I'm printing here. Its name is array. In this next step, you would say I create a new variable, array1, and I just copy the variable array into it. Then I'm gonna do this change here on the first line, and the first line I will just put zeros. And okay, so that just did what you would expect, right? Now I have this array1, and the array1 has only 0 rows in the first row. That's what happened here in these 2 lines of code. Now let's check again our original array. Oh no, look at that. The original array also has zeros. But I mean, in the original array, we had 0, 1, 2, 3, 5. And we haven't done anything to array, right? What we did is we seemingly copied it into this new variable, and we changed that one. But as you can see, what actually happened is that by changing array1, we also changed the original array. And that's a big problem, right? Where does the problem come from? Well, let's take a look at this. We haven't seen this so far, but we have this function called id. And this function id, it gives you the physical address of the object in the computer. So for example, you have a variable x, and so again, now going back to the beginning, what is a variable? Actually, variable is just a pointer. It's just a sign that says this guy is here. You call X, it's like a name, and the name just points somewhere in the computer to a place. It doesn't point to an actual object itself, but it points to a place in a computer memory, where sits the data that you have put there or somebody else put there. And so this ID function, if you feed it with the name of any kind of variable that you have created, it gives you the physical address, that spot in the computer memory where this thing points at to. And if you look at that, for array and array1, that's exactly the same space. So that's the problem here. So here with this line of code, what happened is we did not create a new object in the memory. We did not have, at this point, we do not have two arrays, array1 and array. No, the RR and RR1. No. What happened here is we just copied the pointer. We just copied the sign. And now there are two signs. One is called RR1 and it points here. And there is also the original RR that is here. And they both point at the same place. So now if you use any of them to call them and you do something, when you're changing the actual physical object in the computer, you're changing the same thing. And this is a big problem. So we're going to be talking about this, about really copying objects, because this has something to do with also what is called the mutability and immutability of the object. If you can change the object, if you can change inside of the object. So we're gonna be talking about this in the next lecture. So I'm not gonna get into the details here. And also they're different depending on what kind of a type of object you're working with. The way how to deal with it might be slightly different. So for example, I mean, this person here, for example, they bypassed this problem, right, by assigning the variable RR2 as 1 times RR. So here now this creates actually a new physical array, right? Because this tells me create the array that is 1 times the original array. So it cannot store here. Here we just do this array, just copy the pointer into the array. But here it says, here this operation here, it creates a new array. Another way is RR3 is RR, and now if you use this method of accessing the array, right? Look, that creates again a new array. So if you want to be, so like I said, we're gonna be talking about the details later, but I understand maybe for you want to be really copying arrays, and you don't want to be rewriting the same line of code. So what you can do is with the array is you copy it in this way. Yeah. So this means takes this operation here. This creates a new physical object array. This operation simply copies the pointer. All right. So that's all for today. Thank you.